Hello, my name is Hugo Gabriel. I'm currently an integration and test engineer and a United States Marine Corps veteran. I have a bachelor's degree in mechanical engineering, and I'm currently completing my master's in management of technology at NYU, along with the data analytics course provided by Savvy Coders. I'm currently pursuing a possible position in automation or as a project manager. I feel it's very important to continuously expand my knowledge within my field in order to better myself and those around me. That is why I decided to take on the opportunity to participate in Savvy Coders Data Analytics Bootcamp. I chose Savvy Coders in order to further understand data analytics by utilizing tools such as Python, SQL, and Tableau. I hope to one day be able to transition the skills acquired in Savvy Coders Data Analytics Bootcamp to real-world projects in order to further enhance the team's ability to achieve exemplary results. For my capstone, I've always been fond of all things mechanical. My current main hobby lies within the realm of horology. Horology is a study of timepieces, measurements of time, and watchmaking. A very popular conundrum is stating that you cannot put a price on time. However, some data shows that some timepieces increases in value significantly as they get older. Confusing, right? My capstone project will explore this question as I intend to compare some timepieces to the passive capital return of the most popular index funds and the real estate market within the United States. I hope that my capstone project will demonstrate that timepieces themselves can very well outperform even the most conventional forms of cumulative capital over time. So question, can luxury watches increase in value over time? Can they outperform the US real estate market and most popular index funds? Throughout my research, I came across 3 ways that data is able to demonstrate how specific luxury watches increase in value over time. That is due to luxury watches being resold in the gray market, resold via auction, or being held onto by heirloom. They accumulate value by rarity, age, mechanical attributes, and the type of precious metals that it is constructed of. Top 5. Here I'm demonstrating a brief sample of the top 5 luxury watch brands. The world of horology has many brands and many popular watch collections, but I decided on these since they are more widely known. The following data is a brief representation of retail price versus the maximum resale value. These are data points I was able to collect by visiting their respective brand websites and by collecting the max resale value in the gray market and via auction websites. For this slide, I was only interested in one piece of the data per site. I collected this data and created my own using Excel. That data is the maximum and the retail price. As you can see here, Rolex, I decided to look specifically in the collection of the Rolex GMT Master. Retail value for that is $40,600, and the maximum price I was able to find via resale gray market websites is $204,600. As you can see here, that is a significant increase, and I will further demonstrate how I was able to come up with that number and through my data collection. Over here, I narrowed down my data sets via the collections. I decided to work specifically with Rolex. So there are many popular watch brands, but due to popularity, I chose Rolex due to not only the popularity, but visibility and the appeal that it has in the watch world and to the general audience. To be more specific, I based my presentation off for the most widely known model, the GMT Master. I chose this collection based on the data I collected via Kaggle. This graph demonstrates that the GMT Master has a maximum resale value of $204,600. The GMT Master via this data set has the most data points, and that's why I decided to base off of my capstone off of this specific collection. And we'll go into further detail to be able to see the gradual increase throughout time in respect to the other forms of accumulative capital or investment options. So here I have my initial code. For this capstone, I gathered the majority of my data sets via Kaggle, but I was mostly interested in finding data that can demonstrate change over time The majority of the data graphs and plots will be in time series. Throughout my Capstone, I utilize Python libraries such as Pandas for their effortless manipulation of the data. I use matplotlib for plotting, Seaborn for statistical graphics, and NumPy for efficient calculation with arrays. I also use SQLite for breaking down and analyzing larger data sets that I was working with. For example, this specific data set here. This is the real estate market within the United States. It had over 400,000 entries, so it required a lot of cleaning and wrangling. I use Excel for the cleaning, organizing, joining, and for simple mathematical calculations such as percentage. And finally, I use Tableau for the powerful presentation tool feature that it supports. Within this simple Python code, I was able to use the df function to check and read or input the CSV into this working code so I can then drop the certain columns that I did not require or found unnecessary for my representation. As you can see here, I also decided to drop all the null values. And I wanted to clean up the sold date format because as I was working throughout this type of data set, I realized that the date would probably be a problem. And then finally, I decided to export it as a new CSV file so I can further analyze and then input into this representational graph here to show the nice, slow, steady increase in value over time. This data set this graph demonstrates the data sets I collected via these specific states within this certain given time period from 1979 to 2006. I'll be working generally with just New Jersey data set to show a better representation of that steady flow, increase in value over time. But for now, this specific graph will give you a nice, easy visual representation that can be easily looked at. As you can see for New York, nice increase. For index fund, I decided to narrow it down as well and just only utilize the S&P 500. Data set I collected had a range of 2013 to 2023. This one was a simple data set collected via Kaggle as well that I didn't really have to do a whole lot of manipulation and wrangling. I just easily imported it. And Tableau was able to give me a nice visual representation here. As you can see, minimum 1658, maximum will be 4020 by 2023. For my Rolex data set, I decided to actually plot this via using Python. I felt that it would probably be a better representation since it was a smaller data set. The data I collected was via the website's specific data points, and in doing so, I was able to create my own CSV file with the specific points in the correlation to the given time, generic watch collection GMT master beginning at time 2008 up until 2023, although this graph only demonstrates to 2020. You can see here, nice, very huge significant jump between 2016 and 2020. As you can see here, this is the retail value versus the maximum price. For this code, decided to utilize all these libraries to basically create a Python code with the def and function. This df function will be able to read the CSV file, and this loop function here will be able to, or this def will be able to gather the plotting points via matplotlib, and so I can get this representation of the graph as a time series. In comparison, I took all three of the data graphs and I wanted to have a nice, easy to read and easy to look at comparison between all three types of investment options. As you can see, they all have a nice gradual increase over time. But however, the luxury watch brands have that nice big rocket ship that we all want to see. If you want to be more conservative, clearly you can go with the index fund S&P 500, as you can see over here. And within a larger data set, we want to be able to identify that the U.S. real estate market will continue to increase as time goes on, but you can tell that there will be certain drops at certain time periods. So you have to be a little bit flexible there. As a result, after viewing and reviewing most of my code, I was able to come up with the conclusion that, and using simple Excel mathematical functions, I would take the new number over the old number and multiply by 100. You can see here, the New Jersey real estate market between 2013 and 2023 would have a steady, nice, clean, good number, 158% return based on what the data I was able to find and collect. For the S&P 500 between 2013 and 2023, you were able to calculate 322.38% return. And finally, for the Rolex GMT Master 2, 2008-2023 timeframe, just that one collection within that one specific luxury watch brand alone, we saw, or I was able to calculate a 2,335.62% return. As you can tell, that is a huge number, big percentage increase in value over time. So yes, that will definitely answer my initial question that this specific model brand very well outweighs the performance of traditional index funds and the US real estate market. Finally, I was able to complete this project using Agile methodology. As a product owner for my group, I was able to be responsible for sprint planning, test and challenge issue organization. Also, I would address the sprint scope after 2 weeks in order to estimate, track, and help the team be more efficient. I want to take this opportunity to thank Savvy Coders for allowing me the opportunity to obtain the skills necessary to become proficient in data analytics and to be able to learn and utilize the tools necessary to create